Right, so we are going to finish up law of sines, and we're going to look more at that case where you have a side, and an angle, and you got to do the inverse trick. Okay, so just a reminder about what the law of sines is, in case you don't remember from yesterday. So sine of alpha over A equals sine beta over B, which equals sine gamma over C. What was one of the types that we learned that you can use law of sines for? Yeah?
Angle side angle.
So angle side angle. Yep, that was one. What was another one? Yeah.
Side angle.
Okay, side angle. That's the one we're going to look more at today because there's 3 different cases that can happen. And there was one more case. Wait, was it the
Side angle.
Side angle. Yep. The first 2, you never have to worry about more than one solution. But side angle, you could have one solution. That was like the problem I just did, number 25. Or what else can happen besides one solution? Yeah?
2 solutions, no solutions.
2 solution and no solution. So that's what we'll focus on today. Okay, we'll do a 2 solution, a no solution, and then we'll pick a word problem and we'll do that one. All right. So here is our problem. Now we will draw it in a second, but without drawing it, how can you tell, looking at the table, that it is law of sines? Yep.
Because we have one row where they're both at.
Yep, we got one row that has everything in it. We also have one row with nothing in it and no way to get anything in that row until we get what first?
Beta.
Yeah. So first thing we have to do is beta. Then once we have beta, we'll have 2 out of 3 angles. Then you can get the third angle. So the gamma, that'll be the second thing. And C, that's going to be the very last thing we do. Okay, we can't do that till the end. All right, so let's set it up to find beta, and then we'll go from there. Okay, find beta. Okay, so what could I put on the left side? Let's have that side represent everything that we know.
35 degrees.
Yep, sine 35 over
6.
over 6. Now the right side, that's going to have to be the variable we're solving for. What goes on the right side? Yeah.
It would be sine beta over b, which is going to be 8.
Sine beta over 8. All right. Now to get sine beta alone, what do we have to do on both sides? Yeah.
Multiply both sides by 8.
Multiply both sides by 8. All right, so now we got sine beta alone. And we want to do a little bit better. We want to get beta alone. So what would we do next to get beta alone on the right? Yeah. Yeah, we take the inverse sine of each side. So it's the inverse sine of everything on the left. Sine 35 over 6. And when you take the inverse sine of what's on the right, sine is gone. All right, now we just need to type that in. Okay, one of 2 things will happen. We're either going to get an error when we type it in, or we're going to get a number. Okay, if we get an error, it's no solution. Before I type it in, any questions on how I got what I'm typing in?
Is that negative, so the inverse sign only be for numerator, or is that for the entire thing?
That's the inverse sign of this entire argument.
Okay.
So the parentheses are there to tell you that that's the argument for the inverse sign.
Okay.
So inverse sine 8 sine 35. Make sure you close the parenthesis after the 5. Divided by 6. Okay, so if you tried it, you should have gotten 49.886. Anybody get 49.886? Okay. All right, let's write that down. So what we know at this step is this is not a no solution. There is a solution, okay, at least one. Now we're going to check if there's a second one. Okay, so what do we do to check? Well, let's start. What do we do to find the second solution? We'll check if it works after. Yeah.
Don't we subtract 49.86 and 35 from 180?
Not to check for the second solution. Yep, wait.
I thought I had it better.
You subtract the answer from 180.
You subtract that from 180. That's it.
Okay, that's why I thought it was.
So if there's a second answer, it's going to be that number. I'm not going to write it yet, but that's what the second answer would be. Now, what angle were we given to start the problem?
Alpha.
Alpha, and how much is it?
35 degrees.
It's 35 degrees. Can you fit what we think the second answer would be, 130, and 35 in the same triangle?
Yes.
Yes, because it doesn't go over what?
180.
Yeah, it doesn't go over 180 this time. So because you can fit what we think the second answer is and the given in the same triangle without going over 180, you need to write down that second answer. So what we're going to do now is we're going to call the first one beta 1, and we'll call the second one beta 2, 130.113. Actually, no, 114. Now, for the rest of this, we are now doing two problems at the same time. We're using the same table to do it because A, B, and alpha are part of both problems we're doing. Okay, all the given information is part of both problems. That's why we use the same table. So now if beta has two answers, that means gamma will have two answers. And what else will have two answers?
C.
Yep. All right, now, in terms of the two problems we're doing, alpha, beta 1, and gamma 1 are three of the angles in the first problem we're doing. Alpha, beta 2, and gamma 2 are the three angles in the other problem we're doing. Alpha is shared. It's in both. Right? And same thing with the sides. A is in one of the problems. B is in one of the problems. And C1 is in one of the problems. A is in the second problem. B is in the second problem. And C2 is in the second problem. So wherever I put green dots, that represents the sides and the angles for the first problem, and the blue dots represent the sides and the angles for the second problem. So now let's see if we can get gamma 1. Using what we figured out, because you have to, you got to use what you figured out, how would you get gamma 1? Yeah.
Subtract from 180 the beta 1 and alpha.
Yes. So take basically the two green angles and subtract them from 180. So 49,886 and 35. So gamma 1 is 95,114. Now, you have enough information. You could do C1 right now. But what I like to do is I like to just finish off all the angles first, and then I'll go back and do the sides. Can somebody else tell me how I would get gamma 2?
You would subtract beta 2 and alpha from 180.
Yep. So 130 and 65, that's 165.114. Subtract that from 180. Minus 165.114, and that's 14.886. Yeah, 14.886. All right. Now we don't have any empty rows. That's good. Since the last two rows now have information, we can find C1 and C2. Okay, and we're going to set it up kind of like we did for beta. So let me get some more space. All right, so let's do C1. Okay, to find C1, you can think of that's part of the green problem. We need to start with a green row that has everything in it. Which row here would be a good row that we could use? That's part of the green problem and has everything in it. Yeah, A and alpha. A and alpha is part of the green problem and the blue problem. It's part of both problems. So I would use A and alpha. So sine 35 over 6. And if you want to set up C2, we can start with that too. Sine 35 over 6. All right, now to find C1, what angle do we use? Yep.
95.114.
So sine 95,114 over
Oh, C, sorry. C1.
C1. And then what angle are we going to use for C2?
14.8.
Sine 14,886 divided by
C2.
C2. All right. And now we'll cross multiply, and that'll tell us C1 and C2. Okay. When we find C1, it's going to be what times what divided by what?
Six times sine 95.114 divided by sine 35.
Yep. All right, now we'll take that in. And let's do this one. C2. What's this one going to be? Yeah.
6 sine 14.886 over sine 35.
Yep, perfect. 6 sine 14.886 over sine 35. All right. So now just type in what we got and see what we get. So 6 sine 95.114 divided by sine 35. Okay, so it looks like C1 is 10.419. And C2, well, I usually just press second and then enter. Brings up the last thing I just typed. And then just change 95 to 14. 2.687. Okay, so for anyone who was doing those yourself, did you get those two answers? All right, perfect. And that's a two-solution problem. Okay, so something like that, you'd get points for each answer you get right, and that'd be worth more than like a regular problem. It'd probably be worth double because there's double the work.
Can you just scroll down a little bit real quick for a second?
Yep.
I got close to it, but I didn't get the right piece. Oh.
You all set? Okay, I'll take a look at it probably later today or maybe tomorrow.
Okay, thank you.
You're welcome. Have a good day.
You too.
Right, but that's it. That's all your work right there. Any other questions on that?
How did you get the sign on the bottom? Because wouldn't those cancel out? Oh wait, yeah. Because if you're gonna do a negative, are you not doing negative sign?
You mean inverse sign?
Yeah, inverse
Not
sign.
for C1 and C2, no.
Yeah, that's my bad.
No, the only time you do an inverse sign is when the variable is the argument.
Mm,
When you're finding a side, you don't use inverse trick.
yeah, that's my bad. I messed that up.
Okay, any other questions on that? Now, what case did we just solve using the three letters? Yeah,
We solved the side angle.
we just solved side-side angle. So how can that happen? How could you draw two different triangles that share a side, and an angle not between the sides? Well, I'm going to show you. So this is going to be drawn, perfectly to scale. So I'm going to make another triangle exactly like this one. It's going to have two sides the same. It's going to have an angle the same, but they're not going to look like the same triangle. Okay, so first thing I'm going to do is make a copy of that side. Okay, with what I just did, does everyone agree that those are the same?
Yeah.
Okay. Now, I'm going to take this one, make a copy of it, and I'm going to flip it. Now, when I flip it, is it still the same length?
Yeah.
Yes. The length is exactly the same. That is the same as that. So now they share a side. That's the one tick mark. They share another side. That's the second tick mark. Now, the only thing I can do is just make the bottom. And if I group all that together, does anybody see what the angle is that they both have in common? Yep.
Lower left one.
Yeah, the lower left one. Right there. So the angle in the lower left is exactly the same in both. So that's kind of a visual example of how you can take two sides at an angle, keep them exactly the same length, keep the angle the same, but draw two different pictures. That's where the two sets of answers come from. A diagram like that. Okay, and then in our problem, this side, this was like our A. The two tick mark side, that was like our B. And the angle in the lower left, well, I labeled it wrong. That would be our 35. So that would be our A. That would be our B. And that's basically what we just solved. All right, so there's a picture of basically what we just did. So any question on the two solution? All right, so we've done the one solution with side-side angle. We've done the two solution. Well, the only thing left is to look at the remaining case. So let's see what happens. All right, so first thing, how do we know that this is law of sines.
There's a full row.
Yep. There's a full row. So what we're going to do is we're going to be forced to find something first. What do we have to try to find first?
Alpha.
Alpha.
Alpha, beta, kappa.
So let's set that up. Okay, what could I put on the left side to represent a full row?
50 degrees over 1.
Sine of 50 degrees over 1.
Would that just be sine of 50?
Yeah, it's just going to be sine 50. And what would go on the right side?
Sine of alpha over 2.
Sine of alpha over 2. Okay, we don't really need to cross multiply. You're just going to get that 2 on the other side.
Technically, would that make that just sine of 100?
No. No, because this is an argument to a function.
Okay.
It's like if you had the square root of, 5, and you wanted to multiply it by 2, and you said it was square root of 10.
Oh,
Doesn't. It's an argument to a function, so you can't do that. Okay, so just multiply by 2. You don't need to keep the divided by 1 because dividing by 1 isn't doing anything. Okay. And now, what's the last step on both sides?
Inverse duration.
Yep, specifically
Inverse sine.
inverse sine.
Inverse cosine, actually.
So take inverse sine of what's on the left and on the right. Now, before we type it in, I want to just think about the part I underlined. That has to be a number between two things. When you graph sine, does anybody remember the highest and the lowest that it went? Yeah.
Negative 90 and 90.
0 and 1.
No.
Negative 1 and 1.
Negative 1 and 1. Okay, when we graph sine, the highest it went is 1, the lowest it went is negative 1. That range from negative 1 to 1 is what this number has to be between. So if you type in 2 sine 50, is that between negative 1 and 1?
No.
No.
No, it's at 1.53. So what you're basically saying now is if you put a line at 1.53 and you draw the sine function, you're asking where the two cross. That's the answer to this question. Yeah, they don't cross. And if you actually try to type that in, inverse sine of that 1.53, it says that the value you typed in is not in the domain of inverse sine. That's what it's telling you. Okay, it's not between negative 1 and 1. So that means alpha has no solution. So if alpha has no solution, what else do you think that means?
Beta has no solution.
Beta.
Right, because you don't have anything to add to 180, add to 50 to subtract from 180, because you don't know what alpha is. And if you can't find beta, you also can't find the side that's across from it, because you need to have at least something in this row, and you don't have anything, so you can't work with it. So that's an example of no solution. And that's it. That's all you can do with it. Any question on that? So you might see a question on the test with a side-side angle that says to solve it, and I ask you how many triangles can be formed. This was an example of 2 triangles could be formed, 2 solution. This is an example of no triangles can be formed. There is no solution. Because notice what I said, no triangle can be formed. What do you think that would mean then? If I try to take these exact values and make a triangle, what's going to happen?
No way you could line them to make a triangle.
Yeah, they're not going to be able to connect. So let me draw it out. So C is C is 1 unit. Okay, and this does have to be to scale. So let's make C, we'll call that 1 unit. And A is twice as long. Okay, it's 2 units. So just put 2 of those together, and we'll call that A. So, clone, and do it one more time. Okay, so everybody agree that that is twice as long as C. All right. Now, once I group something together, then I get that little green handle on it, which that lets me turn things. I need to be able to turn this one, but it doesn't have the green handle. So what I can kind of do to cheat and get the green handle is group it with something. And then I can make what I grouped it with invisible. But now I have the green handle on it. So that works. Okay, so here's, that's exactly a 50-degree angle. Okay, I used the protractor tool and drew a 50-degree angle. So I need to make sure this side is at 50 degrees. So maybe about like that. Yeah, it's close enough. All right, so there's A. I cannot turn that. I've got to keep it like that. I also can't make it longer or shorter. It has to stay 2 units long. Now, side C, that's the side that's over here. This angle would be beta, across from B. Did they tell me what beta was?
No.
No, then that means I'm free to let beta be anything I can try to make work. Okay. So here's C. Okay, that has to go over here. But you can make this angle at the top anything you want. You can't change the length of that. It has to stay 1 unit, but you can turn it any way you want. Now the bottom side is B. Did they give me B? No. Then I'm free to make B as long or as short as I want, because they didn't tell me what it was. What I can't do is I can't tilt it, because if I start to tilt it, I'm going to mess up this 50 degrees in the lower left. Okay, so that has to stay 50. So the only thing you can do is you can rotate what I have clicked there, or you can lengthen or shorten what I have clicked there. Those are the only 2 things you can do. Will I ever be able to make a triangle?
No.
No. To make a triangle, I'd have to be allowed to do something else. Make that side longer, make that side shorter, or be able to change this 50 degrees by rotating one of them up or down. But there's nothing I can do to make a triangle out of that. So that's a no solution case. All right, any question on that? All right, so let's take a look. So for the word problem, we can pick which one we want to do. I got the one about measuring the height of the mountain, or I got the one about the boat, and it's like a Coast Guard finding the boat thing.
The mountain.
The mountain? Okay, so let's do the mountain.
We're doing mountain.
So both of these problems are basically what you would call triangulation. The idea of triangulation is you've got something not moving, and 2 different people are seeing that thing at the same time and working together to figure out something about that thing. The height of it, where it is, something like that. But the key here is you have to see the same object from 2 different spots. So you can either do it alone, like you stand in one spot, and then maybe drive like a mile over, and then you stand in that spot and do it again. Or you have 2 people at the same time. So in this case, a surveyor is going to measure the height of a mountain, and they're going to take a sighting from 2 different spots. You do need to know how far apart the 2 sightings are. Okay, so this time the surveyor is going to do it 900 meters apart. Doesn't matter what this distance is. You just need to know what it is. And what the surveyor is going to measure is what's called an angle of elevation. So if you imagine like you had like a laser, right? So let's say this is a laser pointer, and I'm trying to tilt this so that it points at a target, okay? And then one end of the laser is like fixed on the ground, okay? So as I tilt it, it makes an angle with the ground. The more I tilt it, the more of an angle I get. If I point it straight up, that's a 90-degree angle with the ground. Right, so that the surveyor is going to use like a transit, look through it, point it at the top of the mountain, and measure the angle from where they're standing to the top of the mountain. Right, and the first time they do it, they get an angle of 47 degrees. Then they're going to back up 900 meters and do it again. What do you think is going to happen to this angle if you back away from your target that you're pointing at? Yeah,
It's gonna get smaller.
it's going to get smaller, right? Like if I was pointing at the light, I'd have to point it up, and I'm standing like almost right under it. I've got to point that up very steep. If I start to move away from it, then I can start pointing it down a little more. So the further away, the less the angle is. So the second angle is 35 degrees. So the three important numbers are 900, 47, 35. Now, in reality, the transit would be on a tripod. So the transit would probably be like 5 or 6 feet off the ground. We're going to assume that the transit is on the ground. So it's not like I'm pointing a laser from here, like at the top of the mountain. We're going to pretend that that it's on the ground. That would mess up our answer by the height of the tripod. But that's all that would do. So it's, in terms of measuring the height of a mountain, it's not a huge deal. But it just makes our problem a little simpler.
So this would be an angle side angle.
Well, that's what we have to see. So we got a lot of information here. What would make it easier to see that it could be that type of problem? Yeah?
Making a diagram.
Yeah, we're going to make a diagram. Now, don't worry about making any shapes. The shapes will just happen in the diagram if you put the objects in the word problem in the diagram. So, what's an important object from this problem that needs to be in the diagram? Yeah? The mountain.
And the surveyors.
And the surveyor, yeah. Same person, just different spots.
Yeah, both the angles.
And we'll put the angles in there. And something else that's really fundamental. Yeah.
The tripod.
So we're going to assume that the transit is on the ground. So we're not using a tripod. But something else that's very, very important. Without this, the mountain wouldn't have anything to be on. Yeah, we need the ground. And we're going to assume the ground is level. All right, so let's see if we can draw this. Here's the ground. And now we got a mountain. Okay, so there's our mountain. And we're trying to find the height of the mountain. And from how many different spots does the surveyor measure? Two. Let's say they measure from here, and then they measure from over here. How far apart are the two spots that they measure?
900 meters.
That's 900 meters apart. Now they're taking a sighting, so from their perspective, they're going to look through something, and they're going to point it right at the top of the mountain. And then they're going to do the same thing from this spot. Now, the goal is to find this. That's the height of the mountain. Okay, straight down from the peak. Okay, so that's a 90. All right, now we're going to fill in our angles. The angle of elevation is the angle from the ground pointing at the peak. What was the first angle of elevation?
47,
47.
35.
And the second angle of elevation, because we backed away a little bit, it got smaller. Would the angle ever go to 0?
No.
No. No matter how far away you back up, the mountain is never on the ground. It might be, lower and lower and lower on the horizon, but it's never 0. Eventually, if you start to move far enough away from the mountain, now you got to start to take into account the Earth curving. So if you move too far away from the mountain, you won't be able to see it anymore because you're going like around the Earth. So, but we're not going to get into that. Okay, so here's the triangle that if we can solve this right away, we'd be done. Okay, so there's our red triangle. And the goal is to find the height. Okay, so we know the height. And we know that's 47. Well, we don't know the height. We know it's h. Do we have enough information to solve that triangle?
No.
No. To solve a triangle, you need to know at least one
Side.
Yeah, you got to have one side. So that is the triangle we want to solve. But we don't have enough information to solve it. Does anybody see another triangle? Might not be a right triangle, but another triangle we could look at. Just try to describe it to me. Like,
Yes.
all right, can you describe what are you looking at?
Yeah, it's 35 degrees. You got, the bottom is 900
Yeah.
meters.
Okay.
And, let's see.
133 angled, oblique angle, obtuse angle going up to the top of that one.
So yeah, we could find this angle
133.
because we know that these two form, they're supplementary. They're 180. So if you're not sure how he got 133, it's 180 minus 47. And that gives you 33. 133.
So you got angle side angle.
So where's the triangle we're looking at though? What are explain to me the sides of it.
You got the side going up.
Two dotted lines
Yeah. And then the bottom line with that entry.
and the 900, yeah. So let's see if we can look at this. Now, what side there do you think we would want to figure out? Because then it'll help us with the red one.
We want to find the far right one.
Yeah, if you find that side on the far right, it's exactly the same as it's the hypotenuse in the red triangle. So you figure out this side on the right, then you know the hypotenuse in the red one, then we're good. Then we can solve it.
So that's opposite, 55 degrees.
So this is 900. This is 35. This is 133. So it is angle side angle. The problem is we don't have an angle and the side across from it. So we need another angle. How would we get another angle in that blue triangle? Yep.
Oh, we add those two up and then subtracting from 180 to get the shorter angle up top.
Yep. So if we add these up, that's going to be 168, which means this angle at the top is how much? 12. There's your full row. There's your angle, and there's what's across from it. All right, so let's call this side, doesn't matter what you call it. Call it C. And let's solve for C. Find C. All right, well, what would I put on the left side? And this is going to represent the full row. Yeah.
Sine 12 degrees over 900.
And what angle am I going to use
35.
to find C?
35.
Yep, sine 35 over C. Now, is C the height of the mountain?
No, it's the hypotenuse of that triangle.
Right. So just remember, C is not the answer. It's what we need to get the answer. So C, let's just figure that out. It's 900 sine 35 divided by sine 12. Okay, so 2,482.875. So 2482.875. I think it was meters. Okay, now as Hunter just said, C is that side right there. What is the position of side H?
Opposite of
That's
47.
opposite the 47. And what's the position of the side across from the 90?
Across from the 90, the hypotenuse.
That's the hypotenuse. So now, because we have a hypotenuse, you don't need to use law of sines. That's a right triangle. So we can use socket law. What trig function has opposite and hypotenuse in it?
Sine.
Sine. So find H. Okay, so sine of, what's my angle?
47.
47 equals, and what would go on the other side?
Opposite over C.
So opposite over, and what can we fill in?
2,482.875.
2482.875. And now multiply that to the other side, and that's the height of the mountain. Okay, so 2482.875 times the sine of 47. So 1,815 point, we'll call it 86. 1815.86 ish. That's the height of the mountain. No mountains in Massachusetts that high. No. New Hampshire, yes. Not in Massachusetts. Because that's,
Is that how they figured out the height of Mount Everest?
I don't know. I'm sure they've done it different ways as technology's gotten better and different. But maybe at one point that might have been a method they used. Yeah. Because yeah, there's about, not exactly, it's 3 feet to a yard. A meter is a little bit longer than a yard, about that much, a couple inches longer. So if you triple that and then add a little bit, that's about what it would be in feet. So this is somewhere over 5,500 feet to 6,000 feet, maybe in that area.
Isn't it 1 meter is 3 feet? Is that what you just said?
Well, 1 yard is 3 feet.
Oh.
So that's not quite accurate. But if you multiply it by 3 and then add a little bit more, it'll give you an estimate of what it would be. All right. Any questions on that? Okay, so that is the law of science part 2. So homework tonight is 29 to 35 odd, and 39 and 43. So you got about 20 minutes. So please use the time to try to get at least something done. And then tomorrow we'll go over that, and it'll be our last lesson for this week. Okay, and that'll be law of cosines.